Hi and Assalamualaikum. My name is Syazreeana Binti Supardi. My matrix number is 280200. Here, I will explain about application of the 1010 MySTIE framework to the water and food socio-economic driver. Personally, I will share about one application or catch-up technologies which is sensor for real-time supply chain food quality monitoring to reduce food waste. This technology includes 5G and 6G, sensor technology, advanced intelligence system and cyber security and encryption. Introduction: Water and food. Here is some briefing about water and food. Water and food are core to the sustainable development of communities across the globe. This demands a well-integrated ecosystem to ensure water and food security to address the challenge of rising population, urbanization, climate change, and economic disparities. What is the problems or issue the application solves, and what does the application performs? There are now real-time traceability and monitoring systems for agricultural products based on wireless sensor networks. Nowadays, some companies offering real-time sensor-based systems for the food industry to track ingredients over many food miles. What does it mean of a food mile? A food mile is defined as the distance food travel from where it is grown or raised to where it is ultimately purchased by the consumer or end user. This is basically how this application works. It uses sensors to make sure that food from the place it raised to the end user without any of food wasted. Some of the companies have the capacity to create a real-time localized agricultural production, tracking and monitoring system, a food or nutrient security information system. What AI techniques are used in application? AI in water and food. The food industry is not known for its early adoption of technology, but spurred by innovative startup, artificial intelligence AI may prove the exception. AI is essentially programming computer, so they can receive data, evaluate it, make a decision based on the evaluation, and then perform a given task based on the decision. This emerging technology help water and food companies with supply chain management through logistics, predictive analytics, and transparency to reduce food waste. Here are some examples AI used in food industry. First is for developing new product. Castlecraft AI purports to help food companies to know their products will be a home run before they even hit the shelf. Their technologies use machine learning and predictive algorithms to model consumer flavor preference and predict how well they will respond to new tastes. Next is for sorting food. One of the most time-consuming processes in any facility that receives fresh product is sorting. For example, sorting out off-color tomatoes will help decrease rejection by the retailer or consumer. TOMRA Sorting Food develops sensor-based optical sorting solution with machine learning capabilities. Next is to managing the supply chain. Food industry is using AI to improve supply chain. Food safely monitoring and testing product at every step of the supply chain. There are more accurate forecasting to manage picking and inventory. Tracking product from farm to consumer to product transparency. And lastly is to growing better food. For example, AI could help farmers actually grow better food by creating optimal growing conditions. There is a company that using AI to monitor the effect of variables like UV light, salinity, heat and water stress on basil. With the data, they are developing their recipe for the perfect crops. Is there a need for the application to be applied on the said problem, issue or task? Basically, it is a need for the application to be applied because logically it is out of human ability to make sure the water and food are always in good condition without being wasted all the time from where it is grown or raised to where it is ultimately purchased by the consumer or end user. Other than that, AI also can operate 24 hours without interruption or break and has no downtime, so that it can make every work going smooth and save more time. How does the application work? Sensor is used to do real-time traceability and monitoring system for agricultural products while using wireless sensor network and other advanced intelligence system. For example, there is company that helping to solve food tracking problem within the food industry, in part by monitoring real-time data about product, their environment and their movement so that they can track the condition of the food and can reduce food waste. What are the benefits of having that said application? Some of the benefit of the application set is reduce operating and warehousing costs, improve efficiency of food quality, and also world food supply chain is changing for the better. That's all from me. Thank you.
The next AI application being used is nanomaterials for efficient water desalination and water treatment plants. This AI application is about nanomaterials and nanotechnologies have been shaping the wastewater treatment process unprecedentedly. Bibliometric methods are regarded as an indispensable light to guide direction in scientific domain. Thankfully, nanomaterials and nanotechnologies give us more options. The next generation wastewater treatment and water supply system relying on it. It can be high efficient, environmental friendly, co-product free, and also as well as economical feasible. The application solves issues such as water availability, clean energy generation, control of drug-resistant microorganisms, and food safety. AI techniques that being used in the application are artificial neural networks and support vector machine. These two AI techniques are being popularly used as they are less cost-effective when compared to big data mechanisms. Artificial neural networks and support vector machine algorithms are supporting to build water plants that give updated statistics about the present resources and aid to build models for the upcoming situation. Software programs armed with neural network strategies water operation dynamically. It is also helping in developing the present water resources. The decision-making abilities of AI can optimize and automate of the available resources. The governing bodies and water concern department can understand real-time water loss and misusage with an AI-driven planning. This application has to be solved using AI rather than solved using conventional system because desalination of seawater is a power-hungry process, one that tends to use fossil fuels. At an early stage, around the mid-20th century, the results were achieved by water evaporation. However, the process was costly and slow, a fact that led to the search for new, improved technology. By solving using AI, required between 5 and 6 times less energy than reverse osmosis. One of the latest advances in this field has been made by a team of researchers at the University of Pennsylvania. They have created a water desalination process called battery electrode deionization. BDI system. Although the development team is confident about future application once the technology is somewhat more mature. This application work by wastewater treatment system is the junction point between sewage and the natural sources of water such as rivers, lakes, reservoirs, and groundwater. Consequently, effectiveness of wastewater treatment system will produce a great impact on water recycling. In many cases, appropriate treatment of wastewater guarantees the safety of drinking water and resources recovery. Nanomaterial provide high performance in wastewater treatment with main application of adsorption, membranes and membrane process, photocatalysis, disinfection and microbial control, sensing and monitoring. And also engineered nanoparticle find a way into wastewater treatment plants and shown the possible influence on the disposal process. Also controlling physicochemical factor affecting this toxicity in order to dispose of more safe nanomaterials, which is also can harnessing greener synthesis of them to bring down the environmental impact of toxic reagent, waste and byproducts. Benefit of having this application which are the carbon nanotube membranes can remove almost all kind of water contaminant including turbidity, oil, bacteria, viruses and organic contaminants. It is also can remove negatively charged contaminants such as viruses, bacteria and organic and also inorganic colloids at a faster rate than conventional filters. While the current generation of nanofilters may be relatively simple, it is believed that future generation of nanotechnology-based water treatment devices will capitalize on the properties of new nanoscale materials. Water purification based on nanotechnology has not yet led to any human health or environmental problems, but the team echo the sentiment of others that future research into the biological interaction of nanoparticles should be carried out.